Right, so let's try this past examination question. So it's a Core Mathematics C3 Edexcel paper from January 2008, and this was question number 2. So let's have a read. So a curve C has equation y equals e to the 2x tan x, and in part A showed that the turning points on C occur where tan x is equal to -1. So let's attempt that particular part first. Let me pick up my favorite color, blue. So in part A, so we have y, so the curve equation is e to the power 2x multiplied by tan x. Now we need to apply product rule to differentiate. Now let me explain the reasoning. Now we need to show that the turning points on this curve C occur where tan x equals -1, and if I take my red pen, now remember, for turning points the gradient of the tangent at those points equates to 0. So for turning points, so TP denotes turning points, dy over dx, which means that the gradient of the tangent at that turning point is equal to 0. So in order for us to apply that condition, we need to differentiate. So we need dy over dx, and in order to calculate dy over dx in this instant, we need to apply product rule, since we have a product of two terms, both in terms of x in this case. So by product rule, so let me rewrite the product rule. Dy over dx, so that would be v du over dx plus u dv over dx. Now let me choose the first term, e to the 2x. Let me take that to be my u, and let me take the remaining term tan x to be my v. So let me continue. So I'm going to do a side calculation. So my u I've taken to be e to the 2x, and for the product rule we need du over dx. So when I differentiate e to the 2x, we're going to get e to the 2x multiplied by d by dx of 2x according to our chain rule. So when I differentiate 2x, we're going to get 2. So if I go one more stage, 2 times e to the 2x is 2 e to the 2x. So that is what you should have as far as du over dx is concerned. Now if you're unaware with differentiation, if you're unaware with any subtopic of differentiation, I have created videos on differentiation, and I'll provide a link to those videos in the description below. So be sure to check out those videos. Now we also need dv over dx. V is tan x, so I'm going to do another side calculation. So v is tan x, so that would make dv over dx. So let me scroll down a little. So when I differentiate tan, we get sec squared. So dv over dx should be sec squared x. So I have du over dx, I have dv over dx, we have u and v. Let's replace in our product rule. So dy over dx, that is equal to v. V is tan x, so let's replace by tan x. Multiply by du over dx. Du over dx is 2 e to the 2x, so 2 e to the 2x. Plus according to the rule, so plus u in this case is e to the 2x, so e to the 2x. Multiply by dv over dx, and dv over dx is sec squared x. So multiply by sec squared x. Now let me continue further, so let me scroll down a little. So dy over dx, that is equal to, So let me factorize this. So let me take a common factor of e to the 2x, since I have e to the 2x terms appearing. So if I factorize, if I take a common factor of e to the 2x, we're left with 2 tan x plus sec squared x as a result. So that's what we're left over as a result. Now if we go back to the question, we need to show that for turning points to occur, turning points occur where tan x equals -1. And remember the condition that I've outlined here: for any turning point, dy over dx, or the gradient of the tangent at that turning point, is 0. So let's follow this through. So let's apply the condition. So for any turning point, dy over dx is equal to 0. So here's our answer for dy over dx. Let me copy that down. E to the 2x into 2 tan x plus sec squared x, and that is equal to 0. So in this case, so either e to the 2x is 0, and this equation is meaningless. So in this case, I'm going to mark that, indicate that with a cross, meaning that it's meaningless. Or 2 tan x plus sec squared x is equal to 0. So let's work on this equation over here. Now if we go back to our question, so it says that show that the turning points on C occur where tan x equals -1. So if we go back to our answer, we're far from finished. Now we have a trigonometric identity that connects sec with tan, and remember this trigonometric identity, so this is one of the Pythagorean identities. So let me use a red pen. So since sec squared x is 1 plus tan squared x, so if I go back to blue and if I replace, I'll get 2 tan x plus sec squared x, which is 1 plus tan squared x, and that is equal to 0. And if I reorder the terms to make it a quadratic, so bringing the tan squared x to the front, I'll have tan squared x plus the 2 tan x which follows, plus the 1, and that is equal to 0. So if I factorize this, so this factorizes to tan x plus 1 squared, which is equal to 0. And if I take a square root on both sides, so taking a square root on both sides, so by square rooting both sides, so if I apply a square root on both sides, so the left hand side will be, as a result, tan x plus 1, and if I square root the right, we'll have 0. And lastly, taking the plus 1 to the right, we're going to end up with tan x equals -1. So that is exactly what is required as far as part A is concerned. Okay, right, so let's have a look at the next part, part B. So here is part B. So part B, let's have a read. Find an equation of the tangent to C at the point where x equals 0. So once again, if you're unaware in terms of calculating the equation of the tangent and the normal, I have created a video on this, and I'll provide a link to this video in the description below. However, let's go through the steps. So for the equation of the tangent, we need the gradient of the tangent. And for the gradient of the tangent, we need dy over dx. So for dy over dx, here is the answer. So it's e to the 2x into 2 tan x plus sec squared x. Okay, so let me copy that down. So we have, so for dy over dx, whoops, so for dy over dx, we had e to the 2x, so e to the 2x, into, let me remind myself, 2 tan x plus sec squared x. So 2 tan x plus sec squared x. And let's find the gradient at the point x equals 0. So that will be the gradient of our tangent. So let's work out the gradient of the tangent. Now I usually call my tangent gradient m1. So in order to calculate m1, the tangent gradient, let's put this x value of 0 into dy over dx. So that should give us e to the 2, x replaced by 0, inner bracket 2 tan x replaced by 0, plus, and in trigonometry, sec is the reciprocal of cos, so sec squared will be 1 over cos squared x. So it's going to be cos of x, which is 0, being replaced. And don't forget to square that. There we go. And if I simplify in the next line, now if I pick a red pen, now e to the 0 is 1. Tan 0, so this term is 0. Cos 0, that's a standard result, cos 0 is 1. So as a result of these notes, let me go back to my blue pen, we'll have 1 from here. So it's a 1 into, so 1 into 2 times 0 is 0, plus 1 over 1 squared is 1. So I make my tangent gradient 1 times 0 plus 1, 1. So this one is the gradient of our tangent. Now, for the equation of the tangent, so we need the equation of the tangent, bearing in mind, we need the y coordinate which corresponds to x equaling 0. So to find the y coordinate, we simply put the x coordinate into the curve equation. So let's follow through. So if I put x equals 0 into the curve equation, so here's our curve equation. So y is e to the 2, x replaced by 0, multiplied by tan, and x replaced by 0. Now, as I mentioned earlier, tan 0 is 0, and this e to the 0 term is 1. So bearing in mind these, we're going to have 1 times 0, which is 0. So that's the corresponding y coordinate for when x is 0. And now that we know the x and y coordinate, the coordinates of the point where the tangent passes through, and we also know the gradient of the tangent, since the tangent is a straight line, let's use the straight line formula to work out the equation of the tangent, and in this case at the point where x is 0 and y is 0. So let's use the straight line formula, y minus y1, that is m into x minus x1. You could also use the standard equation of a straight line, y equals mx plus c, to work out the equation of a tangent, but I prefer to use this formula. And our tangent passes through 0, 0, so our x1 and y1 are 0 and 0. Whereas m in this formula, this m is the gradient of the tangent, which is m1, and m1 we had 1. So let me group the data and let's apply the data here. So we have y minus y1 is 0, and that is equal to m being 1, so it's a 1 into x minus x1. X1 is 0, and if we multiply the brackets, y minus 0 on the left is simply y. 1 times x is x. So this should be the solution for the equation of the tangent to the curve C at the point x equals 0. So that concludes part B, and that sadly ends the video as we completed the question in its entirety. So I hope you enjoyed this video. If you did enjoy the video, be sure to subscribe, and I hope to see you again. Thank you.